Hello again, my friends, in your channel Math Made Easy. And as I promised, I'm going to introduce another method of finding the inverse of an invertible matrix. And maybe we'll use the same example I used with the other method in the previous session, just to emphasize, you see the similarity and differences between the two methods. This method is based on the cofactor, if you remember. Remember what we did previously when we were talking about how to find the determinant of a matrix? So basically, that's what we are going to do, but then we expand until we find the inverse of the matrix. And the steps are as follows. Step number one, I'm going to find the matrix of minors. And those experienced in you will just ignore that step. I don't need it, right? Because you can go to the matrix of cofactors very quickly, right? Remember how we did it last time? But if you don't know how to do it, you want to play it safe, find the matrix of minors and then change the sign of the diamond inside, as you will see. Step number three, find the determinant, like we did last time, of the matrix. If zero, stop, no inverse. Okay. Step number four, find the transpose of the cofactor matrix. What's the transpose? If you don't know, very simple. You make the rows columns and the columns rows. So reading the first row from left to right, you're going to write it from top to bottom. The second from left to right, you write it from top to bottom, and so on. And that's it. Finally, five, the inverse equals. By the way, when we find the transpose of the cofactor matrix, we call that the adjoint matrix. And the inverse is adjoint divided by determinant. That's why if the determinant is zero, you stop because you cannot divide by zero, meaning there is no inverse. Five very simple steps, or even four very simple steps. Let's take the same example we had last time. Remember, we had these three equations in three unknowns, and we solve for x, y, and z. So let's pick the same matrix and see how we are going to do it. So to find the inverse, and then of course, after you find the inverse, you're going to multiply it by the right-hand side, right? But here, I'm not going to do it again because we'll get the same inverse, and we already did that. I'm just showing you another method of inverting a matrix. So here is matrix A, 1, 2, 3, 0, 1, negative 3. Oh, I'm sorry, no, it was 1, 2, 3, 2, 5, 3, and 108. Okay, so let's play it simple. Find the matrix of minors. I'm going to call it M for minors. And many of you already know how to go directly to the cofactors, but let's do it. We said to find the matrix of minor. We are going to, so for example, if I want the minor of 1, I'm going to hide the row and column in which the 1 occurs and evaluate the determinant of the resulting 2 by 2 matrix. 5 times 8 minus 0 is 40. So I write 40. And then I find it for 2. 2 times 8 is 16, minus 3 is 13. Then I'm going to find it for 3. 2 times 0 is 0, minus 5 is negative 5. Then for the 2 times 8 is 16, minus 0 is 16. For the middle number, 1 times 8 is 8, minus 3 is 5. For the 3, 0 minus 2 is negative 2. For the 1, 6 minus 15 is negative 9. For the 0, 3 minus 6 is negative 3. And for the 8, 5 minus 4 is 1. Not hard, right? Very simple. Now, let's move to the matrix of cofactors. This cross stays the same. So 40, 5, 1, negative 5, negative 9. As for the diamond, this diamond, I change the sign. So the 13 becomes negative 13, the 16 becomes negative 16, the negative 2 becomes positive 2, and the negative 3 becomes positive 3. Okay, and next, we are going to calculate the determinant of A. And we say the determinant of A equals. I can pick any row or column and multiply it by the corresponding row or column of the cofactor and add all these terms. If you are lazy, we can use the second column because there is a 0, or the third row, it has a 0, right? So let's pick, for example, the second column. Second column. 2 times negative 3 is negative 26. 2 times negative 13 is negative 26. 5 times 5 is 25, and 0. So the determinant is negative 1. Okay? You can pick any other row or column just to check to see if these numbers are correct or not. But we don't have to do that. But once we know that it's not a 0, we know that there is an inverse for this matrix. We already knew that, of course. Next, we'll do the adjoint of A. Remember, we said the adjoint is the transpose of the cofactor. So I'm going to take this cofactor and find the adjoint of A. First row is 40, negative 13, negative 5. I'm going to write it from top down. Negative 16, 5, 2. Negative 9, 3, 1. And finally, I get the inverse of A, which is this matrix I just found. Of course, I don't need to write it like that, but I'm just showing you what we will do, divided by negative 1. How do you divide a matrix by a number? You said, oh, you said there is no division in matrices. No, I mean, you cannot divide two matrices by each other. But you can divide the matrix by a constant because this is the same as multiplying by the reciprocal of the constant. If I say 2a, I multiply each element by 2. If I say negative 1a, I multiply every number by negative 1, meaning change all the 9 signs. Negative 40, 16, 9. 13, negative 5. Did we transpose? Yeah, we transpose that. That's the adjoint. So we are dividing, changing those. 5, negative 2, negative 1. Check. Negative 40, 16, 9, 13, negative 5, negative 3, 5, negative 2, negative 1. Very simple. For a 3 by 3, all what you have to do to find the minor or the cofactor directly is to evaluate the determinant of a 2 by 2 matrix. Multiply them. So if I want the minor of 1, I multiply the elements on the main diagonal and subtract the elements on the other diagonal. And that's it. Okay? I hope this was an easy one. I did the 16 correctly this time. I know how to do my math. Mental math. I can multiply 2 times 6 and 7 times 3 in my head. Yeah, I can. Anyway, thanks for your time and hope to see you soon. Next time, we are going to learn the last method in solving a system of linear equations without dealing with matrices at all, without finding the inverse, without finding the adjoint and the cofactor. We'll do it using Cramer's rule. So stay tuned. Thanks and have a nice day.